Alright, so in the previous lesson we built the basic cage. So in this one we'll start building the armor pieces. Okay, so the armor is fairly complicated because it has like a whole bunch of layers on it. So if I just show you the basic armor, then that's effectively what it is. So what we have is we have the base shape, and then we have these smaller cuts in there, and then we have the bigger cuts, and then these sort of connectors. Okay, so this is going to be like, we'll do a two-part lesson for the armor, and then we'll do a third lesson for building the connectors. So that's roughly what we are going to do. So just to get started, the first thing we need to do is the problem that happens with Voronoi fracturing is that they give you these, you end up getting like these 5-sided pieces, and that looks a little boring. So what we want is we want to generate like connected pieces. We want to generate clusters. So the first thing we need to do is we need to come back to the chest cuts that we had done, and we are going to add something here called a cluster. Okay, so if you do a search for cluster, you'll get something called cluster points. And if I just drop that in the middle, then you'll immediately see a difference, right? So what happens is it starts to sort of like generate clusters out of these pieces, which is good, right? So now what you're getting is what is like, initially what you have is like, you have like one piece that looks something like this, and you'll have another piece that looks, you know, something like that. But if I connect these two pieces together, then I'll get something that looks, you know, a little more interesting. So I'll end up getting a piece that looks like that. And that's effectively what clustering does. See, so now you're getting these nice little lines that are flowing, which looks a little more interesting than what you were getting before. And you don't really need to do too much, right? You can define the number of clusters you want. So we can, I think 10 is good enough. And these will also change on a per frame basis, because the whole shape changes, so this automatically updates. So the first thing is it will generate an attribute called cluster. Okay, it's an integer attribute, which we will have to bring it into our Voronoi fracture. So just bring in cluster, and then we just want the out chest. Like the breast I'll deal with separately. I just want the chest at the moment. So I'll just take another object merge, and we'll just drop in the chest over here. Or actually we don't need to do that, right? Because it's already here. So I'm just going to take this, do Control C, Control V, and just bring it out. And what we can do is I can just select this, and I can, like, let's do one thing. Let's just bring this a little further down. Okay, so we have a little more space, and yeah, let's just move this up. I'll just take this, make a network box for it, and we will give it a name. So I'll just call it, this is the cage. And what you can do is you can right click here, and you can say, or actually no, let's not make this. Let's not make a network box. Let's just give it a label. So I'm just going to take this, I'll call it cage. And what you can do is you can right click here and say text size is large. And we can make this, I think this is too huge. And I can make this invisible. So you can say hide background. So what happens is you can just get this, and you can kind of move this around. Yeah, and I can just place this here. Yeah, so you just get like a name on top of it, basically that. Okay, so I can just take this here, and we can start work on this guy. So I have this, which is perfectly fine. The first thing we want to do is I want to randomly delete pieces out of this, because I don't want like a single continuous armor. I want to have like, you know, hollow pieces in there. So if you remember, we had created an attribute here called C, which is storing the point number. So each one of these pieces is storing a value which is the point number. Okay, so if I was to check this, if I say, do I have that? Yeah, I have the geometry spreadsheet. So if I come down here, and if I look at it at a primitive level, and you should have something called C, and see what you can see here is like it's 2 for all of those, and then there's 3 and 6. So each point number is being stored here. And so what I can do is I can use that to just delete faces or delete entire pieces randomly. Okay, so I'm just going to come in here and we'll do a delete, and we will do by expression. Yeah, and we'll do a random at C, say less than 0.3, and see. So what you're going to get, let's do +3 or something. See, so what you're getting is, on a per frame basis, it's sort of like randomly deleting pieces. But what I can also do is I can do, like, instead of 3, I can do an at time or an at frame. So you'll get like a random seed. So we'll do an at frame. And so what that does is that every frame you'll get like different chunks kind of, going away, which is interesting. Like, it gives you something different. So you won't get like a single, which is why I kind of built that breast piece, because you never know what randomly it might just end up deleting. So what's happening is, like, this area will always remain covered. I think I might need to sort of move that piece around a little bit. Just give me a second. Yeah, okay. Where's the breast piece? Yeah, okay, there it is. So let me just take this and I'm just going to move it towards the front. Let's do one thing. Let's take another one. We'll do Control-C, Control-V. I'm going to merge them together. Okay, let's just see what that looks like. Yeah, okay, that's not bad. Let's just adjust this a little bit more. What we can do with the box is, if we want, we can sort of delete a point here. Okay, like let's not do this. Let's get rid of that. Yeah. We can come to the point jitter over here and maybe get rid of this point. Okay, like which number is that? The number won't change. Like that's 6, so it will remain 6. Okay, so we can just take a blast, keep it to points and get rid of 6. And let's hope that works. Yeah, okay. So what that should do is it should leave that space open. So what you get is, see, so this remains a little more covered. Okay, so this is good. I don't think there should have been any, like, if you've done everything right, everything should still be working. See, there you go. So now what you're getting is, you're getting that one piece over here, which is like always covered. Okay, so we come back here to our delete, and that's roughly what you're getting. You can define how much it needs to delete. So we can make it, say, 0.1. So it won't delete too much, just a little bit. Yeah. Okay. So, that's the basic thing that we want. Now, what we want to do is, instead of working on each piece, because these are individual pieces, we want to work on, like individual clusters. So what we need to do is, we need to get rid of the name attribute and then build a new one, which will be for the clusters. Okay, because we want each cluster to get extruded and get a shape. So what we're doing is, we're going to take a delete attribute. So take an attribute delete, and we get rid of name, and then we'll create a new attribute based on clusters. So we'll take a partition and we'll do, let's call this P, and we'll do P backtick at cluster. So we should have like a group based on the clusters, and then we can take a name. Okay, get rid of this, or hold on, no. Yeah, get rid of that and say name from group, and we will do P star. So what this should do is, we'll now have a name attribute called P, which is each cluster. So just to check if everything is working, if I do a for each named primitive, I should be able to see each cluster. See, so now, even though these pieces are connected, we are working on, individual clusters. So this gives me a much more interesting, result, because now, like, if I turn this off, see, the shape itself is much more interesting instead of like individual, just, like a Voronoi cell. Okay, so this is good. So we start off by doing a simple fuse. So we'll just fuse all the points together, like all the open points will essentially get fused, but we'll also do a mirror. So I'm just going to do a mirror. So we just fuse everything, increase that value a little bit, just so that everything is properly just merged together. Yeah, I think this is good. Like let's just check it like at the end here, just so that everything looks fine. Yeah, okay. See, so the point is like now it's looking much more interesting than what you were getting before. If instead of just like individual sort of just cellular pieces that you usually end up getting. Okay, so this is good. And now I can just come in here and we'll do a simple poly extrude. So this one we'll keep it like slightly big. So it's about that much. And we can do like an output back. And let's see if it works with an inset. As I said, like the problem that I was facing, no, see the inset sort of like comes till a point and then stops. So what we'll do is we'll just do a small, like a scale over here. So I can just take this and scale it down a little bit. So it looks a little more fancy. See, so now if I look at it, see this is where we are. So you immediately get something that's much more fancy looking. Okay, so the other thing we want to do is I want this to be slightly smoothened out. So let's try something. Let's see what happens if we do a smooth. Okay, let's just do a smooth here. No, it drops down way too much. Like this might look interesting, but not really what we want. Yeah, like this is a little too smoothened out. But what we can do instead is I want to do a VDB. Okay, so let's convert this to VDB. Sorry, not that. We do VDB from polygons. Because the thing I realized is like even though like booleans can get slow, but VDB booleans are actually pretty fast. And this is also the reason why I mentioned you might need to retopologize the whole thing, because once you do VDB, the geometry count tends to go up pretty high. But the nice thing about VDB is that it's easier to get like rounded edges. Okay, like the problem is you don't need to, the good thing is you don't need to worry about doing bevels and stuff like that of, if these points are too close and then they're going to start intersecting and the bevel just won't work. Those problems go away when you're working with VDB. So I'll make the voxel size at 0.01. So you end up getting this. So if you look at it now, see, this is where we are. And then I can just take, see, so if I want to delete a little more, I can try to delete a little more. Let's go to 0.2. Yeah, see, so this gives you something a little more nicer. Okay, so we're here, and then I can just, let's try one more thing, which is, let's try to subdivide this. We'll just take this and I'll make it, like I'll come to poly extrude. I'll give it about 5 divisions, and then let's drop a subdivide in the middle. Yeah, I think this is nice. Yeah, this is much better. So the VDB will look smoother, because what happens is VDB picks up a lot of facets. See, so you'll end up getting, which is not bad. Like if you wanted to look like that, it's, perfectly acceptable. But yeah, we wanted to look slightly smoother. So this will look a lot better. Yeah, there you go. This looks a lot better. Okay. And then I can do like a slight bit of VDB smooth on this, so that it rounds off a little bit. Maybe not that much, just a little bit. Okay, and then convert it back. So we'll do VDB from, we'll do convert VDB and just drop it back to polygons. And there you go. And then if you want, we can do a little bit of adaptivity. We can also try to extrude it a little bit more. So let's make it 0.1. Yeah, and maybe not smoothen it down that much. So let's keep it to 1. Yeah. Or you can try to do like median value, which will be better. Okay, this is good. See, so now you have like a pretty nice looking mesh overall. If you want the colors to be back, okay, what we can do is we can take the fuse over here, which has the color, and then try to transfer it back. So we can do an attribute transfer and just sort of, transfer the colors. So you should get the colors back. It's not necessary, but if you just want the colors back, why not? And so if I just, if I just merge these together, or like we'll just do a null here and we'll call it out armor and do the same thing. So object merge, drop this in, yeah, and do control X. Let's come down here. Yeah, we might need to give it a normal. So let's just come back here. We'll just give it a normal. Yeah, there you go. See, so you have some nice armor being generated. So it slows down now because it needs to calculate the VDB on a per frame basis. But see, so now you're getting like these, because of the clustering, you get these nice little, shapes that you're getting out of it, which otherwise you would just get, as I said, you just get those Voronoi cells, which looks boring and it looks very obvious, like what you've done. This makes it look more fancy. Okay, so in the next lesson, I'll do one basic thing, which is we'll build the holes for the connectors. Okay, so what I want to do is I want to take each, like we've removed the attribute, but we want to go back to each individual piece and find the center of it and generate like a hole or a connector in the middle over there. Okay, so that's what we'll do in the next lesson.